Today, I'll be talking about reasons why building collapse. And I'll be saying specifically in terms of my country, Nigeria, and then Africa as a whole. Recently, a building collapsed in Nigeria, and I was passing around the area and I heard most people saying that it is the fault of the structural engineer. And everybody was saying, oh, this engineer is bad, is bad, is bad. No, that kind of stuff. But basically, most times when a building collapses in Nigeria or anywhere in the world, it's not actually the fault of the structural engineer. Yes, of course, the structural engineer is who everyone would like talk about because that is what he designed and all that. But basically, we don't look out for the material properties, and also we don't look out for if it is the client and all that. Because most times the structural engineer might perform his or her structural design using the specified material selection or material quality properties, and also given the usage of the structure. But you will see that based on the usage of the structure, for example, which is a very common thing here in Nigeria, an engineer will design a building for a shopping plaza and all that. Before you know, after 2 to 3 years, because people are not coming to rent that particular shopping plaza, and then before you know, a church will come and rent that particular shopping plaza to use it for a worship center. Knowing fully well that worship center and a shopping plaza is of different activity. And since they are of different activity, they also have different structural design load and principles. Now, in the course of that, because you are now using what was designed for a shopping plaza for a worship center, it means that the loads used for the design of that structure has changed totally. And this alone can cause structural collapse. Now, don't get me wrong. The design load for a worship center is 5.0 kilonewton per meter square. And the design load for a shopping plaza is 2.5 kilonewton per meter square. Invariably, you can see that we designed the structure for a 2.5 kilonewton per meter square, and what the structure is actually experiencing during its usage is 5.0, which is times 2 of what was designed for, which implies that if basically it was designed as a worship center from origin, you will see that most of the pillars or columns that is carrying 4T16 in a layman understanding, 4 numbers of reinforcement or iron, you will see that it will be carrying like 6 numbers or most times 8 numbers, and the size of the column will be what bigger. But because it was designed for a shopping complex, you will see that the number and the size of reinforcement will be reduced. And if that building during when it's being used was actually used for a shopping plaza, you will see that that structure will last for its design life, which is actually 50 years. But because the change of usage after its construction has now changed, you will see that the structure will be experiencing underload based on the usage of the structure. And this alone can cause structural collapse. I have advised many clients, most of my clients, that see, if I design a building for you, because most times they tend to change what the building was to be used for, and that alone causes structural design. So I always advise my clients that listen, if I design a building for you and it's for a shopping plaza, in future, don't convert it to worship center, for example, churches, because the load sequence is different. When it comes to the material or the construction material in Nigeria, I must say that the construction industry or the manufacturing industry in Nigeria is one of the major causes of building collapse in Nigeria. Why am I saying that? Based on our engineering properties of materials, we use a specified requirement for our material selection and material properties when it comes to the strength of reinforcement or the strength of the cement or concrete. Now, you will see that you can purchase most of these materials in the market. You design for a design property reinforcement of 460 or 410 kilonewton per meter square. Then you will end up at the market seeing that the what is available at the market is 300, most times 380, and not even up to 400 strength of the reinforcement. Now, this alone can cause structural collapse without anyone knowing. And when this happens, you will see everyone saying it is a fault of the structural engineer. One thing again that causes structural collapse in Nigeria is that basically around the world, the actual practice is that if a structural engineer performs a structural design for any structure or any building, during the construction, that structural engineer must be consulted. If at all he will not be the structural engineer at site, you must consult him at least to be a supervising engineer because he was the one that did the structural design. But in Nigeria, the reverse is the case. Why? Because the client feels that he cannot be able to pay the engineer, or one of his in-law or uncle in the village who has over 40 years experience having building buildings, but is not an engineer, have been performing some kind of bricklaying work and all that. And because he have done some building construction over the years, they feel he has quality experience to erect any kind of structure. And then they will boycott the engineer and bring their uncle, which is not even an engineer, into the project. And because that uncle or that auntie or anybody has limited knowledge about the engineering principles, you will see that there will be issue during the design life of that structure because most of the principles was not followed. When an engineer is performing a structural design and also analysis, there are some things he considers during the structural analysis and design that most times they don't implement it or transfer it to drawing because they feel that during the construction they are going to implement what they have in their head. I am saying this not for common structures, for some complex structures. Most engineers don't transfer everything into the paper, like to showcase it on drawing. Now, what means is that if you boycott that engineer and bring in another person that didn't follow during the structural design of that particular structure, you will see that when that stage reach where that that did the design, which is where he made that kind of changes or thought, okay, when I get to the site, I'm going to do this. You will see that at that place, it will cause an issue. For example, a typical example is the world's biggest church, which is the Salvation Ministry. What happened was that an engineer was there that followed during the when we are performing the building drawing for that particular structure. And later, they sacked the architect that performed that design. And when that architect was sacked due to some of the reasons they had, what happened was that they have to employ 3 more architects to be able to understand what that architect that created that drawing from beginning. And it took these 3 architects almost 3 months to be able to understand the vision of what the original architect did. And even at that, they still need to remove most of the designs that they don't understand. So you can see that the same thing happens in the engineering world. When a structural engineer performs a design and at the end, during the construction, the client tends to boycott that engineer and bring in someone that doesn't have enough experience, you will see that most design or most connections will not be followed. And when this happens, then that building might actually experience an issue that can lead to a total collapse or a partial collapse. Another thing again that leads to structural building collapse in Nigeria is our concrete blocks. You might say that why did I use the word concrete blocks? That blocks basically does not carry load. What carries load is the columns and the beam. That is true. That's true. But don't forget, there is what we call load bearing walls. And most clients, because of how expensive materials reinforcement cements are currently, they tend to buy cheaper materials or try to use lower standards of material for their building construction. And when this happens, you will see that most of the loads will be on the block, knowing that it is not every time that most clients uses the principle of frame structure. If you're designing or if you're constructing a frame structure, at that point, the block is not carrying any load. But if it is not a framed structure, then at that point, most of the load of the building is being carried by the blocks. What I mean by frame structure and a non-frame structure, for the lay people that don't understand here, a frame structure, if you look at some buildings when they are constructing the buildings, you will see that they will start only with the foundation, the columns, the beams, and the slab alone. There is no block wall. And that particular scenario is a frame structure. Now, once you see that the building starts going up from the foundation up to the roof, they have not yet started laying any block. It's just standing using the column, which is the pillars, the beams, and then the slab, and then continue to any number of stories they want to go. Now, at that point, if they later come and add block works, that block is not carrying any load. But if from beginning they start laying blocks, and you see that most of the blocks is even what is supporting the slab, at that point, there are some percentage of load from the slab, from the beams, that is being carried by the blocks. And knowing that the blocks in Nigeria is one of the worst block ever I've seen in the world, that you can be able to pieces a block with your hand. But if you go to some countries, even common Cameroon here, common Ghana, you will see that their blocks are very strong. If you hit them on the ground, there is no crack. But in Nigeria, not even just a slap can even break that block. And that is the block that most clients are using as a load-bearing wall. They believe that by the time they apply plaster or plastering, then everything will be bonded together. But that's a lie. That's a lie. Plaster or plastering does not hold block that is not strong. It will only stiffen the surface. But if the actual block is not strong, then you are going to have issues. And don't forget, if your actual intention is to construct a load-bearing wall, then the numbers of blocks that you have to produce per bag of cement will have to be reduced. Most times, 15 numbers of blocks per bag of cement, most times 20 number of blocks per bag of cement. The maximum you can have is 30. That's the maximum you can have. But it all depends on the load that particular block wall is going to receive. That is if you're going for a load-bearing wall. That's buildings that don't have columns and beams, just the block wall and then the slab. It is not common here in Nigeria, but in other countries, US, Belize, South American, Cameroon, Togo, it is all common. That's what they normally use. And basically, it's among the cheapest method or cheapest form of construction. In my next video, I will be telling you more things that causes structural collapse or building collapse. So it is not every time that the building collapse that you are going to say that it is the fault of the structural engineer or it is the fault of the civil engineer. No, most times it is the fault from the client. That is why we always advise every structural engineer, when you're done with your structural design, produce your structural design analysis and your reports and design reports and keep them. Please save them on a Google Drive or any cloud and save it. Because in future, when a building collapses or if that building collapses and maybe due to the client's fault or anyone that did the construction that you are not there, you are the first that they are going to call. And what will save you at the law court is your structural design and your drawings. When you present your structural design reports and then your drawings, and when the committee of engineers comes and look at your structural design reports and your drawings, that two of them relate together, and they look at the strength and everything you've done and everything is suitable, then they will now shift the blames to the clients or they will now go and look at for what was done during the construction. And with that, you will see that you have saved yourself. But if you're not able to produce the structural design of a particular structure at any given time you are being called to produce, then all the blames will be on you. So it's an advice, when you perform any design, please title that particular design report, get your design report and the drawing, put them in a folder, zip it, and send it to your Google Drive. Google Drive gives 15 gig for free, but if it is filled up, you can then purchase the required size you need. I have over 2 terabytes for my Google Drive where I've stored all the design reports depending on and based on the clients. I create folder for each client, put the design report and put the drawings, so that in case in future when you call me, I'll have to produce. Just go to that place and download your folder for you and give it to you and present it at the law court. Because when this happens and you're not able to produce your design report for that structure, my brother, you are going to jail. You are going to jail. And if at all you didn't go to jail, your license will be seized. And when it's seized, everything you have done for over the years will just go into rubbish. I would advise you follow this principle of having a backup of every design you've done. I started designing in the year 2015, and since then, I have all the records of the building I have done so far. Yesterday, I performed a building design that made it 4,000 buildings I've designed in my career as a structural engineer. So, and I have all those records. I've been using Google Drive for a very long time, so I have all those records. The reason why I was able to know this was because of how I was trained. I was trained to always have a backup of every design that I have done. And with that, that has saved me a lot, and a lot. So please follow this principle, and by next week, I'll be making another video and another principle of how to prevent building collapse, specifically in Nigeria and in Africa. Now, you might think that Nigeria is a bit the worst and all that in terms of compromising design standards. But have you been to Cameroon? When you go to Cameroon, you will know that Cameroon is the worst compared to Nigeria. Yeah, Ghana is a bit improving now. Ghana have passed like a law that every structural engineer that performed any structural design must follow up during the construction. It's a law now that has been passed. Most people have started adopting that law and all that. But Nigeria and other countries is not yet following the law in Africa. South Africa has been following that because they are among the second world country. So please, I will be making another video on how to prevent building collapse by next week. But for now, see you again. Welcome to Ekidel.